The lesson topic for this video is factoring completely. And this is a continuation of working with the GCF and quadratics when a equals 1. And there will also be an example using a difference of squares in this lesson. All right, so we've already talked about how to factor out a GCF. So we're going to start every factoring problem with GCF as our first thing we need to do. And if we forget that, we're going to have some problems along the way when we get to the more complex questions. So always look for a GCF first. There is a GCF in this problem because 3, 9, and 54 are all divisible by 3. So I'm going to factor out a 3. Since 54 does not have an x, we cannot factor out an x. Again, I'm going to put my parentheses down like so. And now 3 divided by 3 is 1, so that 3 has been factored out. We have x squared left, minus 9 divided by 3 is 3. So we have minus 3x because the x has not been factored out. And then minus 18 because 54 divided by 3 is 18. At this point, what we have on the outside is our GCF, and then what we have on the inside is a quadratic where a equals 1. So the next step we're going to always look for is factor when a equals 1, which is our two sets of parentheses, or look for a difference of squares. Difference of squares. And again, that still will factor into two sets of parentheses. So in this case, we have a quadratic where a equals 1, so we're going to factor this as we learned in the previous lesson. All right, so I'm going to take this negative 18 off to the side. Now in the previous lesson, I did talk about kind of working upwards with my factors, but with this in the way, that doesn't work very well. So I'm going to look at my negative 18 right here, and I'm going to list all my factors of negative 18. Well, I know 1 times 18 is 18, but we know one of them has to be negative to get to negative 18. And we know 2 times 9 is 18, and one of them has to be negative. And 3 times 6 is 18, but again, one of them has to be negative. Now remember, we could move that negative sign to the other number. We're just going to find out where we need it based on what comes next. So remember, what does come next is we're looking for the two numbers that when we add them, adds up to negative 3. So when I add my values, I get 17 when I add these, I get 7 when I add these, and when I add these, I get 3. So I have the right number value, 3, but I need it to be negative 3. Well, if I simply change the 3 to positive and the 6 to negative, again, they still multiply to give me negative 18, but now they add up to negative 3. So I have found my two factors that will work in this factoring problem. So I'm going to leave my 3 here, and I'm going to put my two sets of parentheses like so. So I need x plus 3 and x minus 6. Again, these two values, positive 3 and negative 6, go in our parentheses. Again, if we were to FOIL the two sets of parentheses, or in other words, multiply these binomials, and then we'd get to here, and then distribute the 3 back in, we would get back to our original expression. Okay, let's try just 2 more examples for this lesson. All right, again, like I said on the previous screen, step 1 is always look for a GCF. We do have a GCF in this problem, and that is 5, because both 5 and 45 are divisible by 5. 5 divided by 5 is 1, and so therefore we just have x squared, or 1x squared left there, our minus sign, and then 45 divided by 5 is 9. At this point, remember, again, what I said on the previous slide, we're looking for either a quadratic that has a equals 1, so 3 terms with a 1 out here. We don't have 3 terms. Or a difference of squares. Difference, yep, we have subtraction, and a perfect square, and a perfect square. So this is a difference of squares, so we are going to be able to factor it into two sets of parentheses with that shortcut. This 5 stays out here. And remember that we are going to write here what value times itself gives us x squared, and that's x times x. And then what value times itself gives us 9, and that is 3. And then we always put a plus in one and a minus in the other. And we have factored that difference of squares, and we of course again leave that GCF out there. All right, our last example for this lesson. This one I want to just refocus us on when the GCF is the first thing we look for, which it is. We want to make sure that if the leading coefficient has a negative, you definitely want to factor out the negative. So I'm going to factor out negative 3 because I know that 3 is divisible by 3, and so is 21, and so is 36. So when we do this, we have to be a little extra careful because we're factoring out a negative along with the 3. So negative 3, we factor out negative 3, we're left with x squared. And then this plus that we would normally just write down right here, we don't, because what this is positive 21 divided by negative 3. So because I factored out a negative, I need this now to be a negative. So if you think about how a negative times a negative will get us to the positive. And that will be negative 7x. And then, again, if we factor out the negative here, then this is now going to be a positive. So now we have plus, and then 36 divided by 3 is 12. Again, to double check, just think about distributing this back in. Make sure you get back to your original. Negative times a positive will be negative. Negative times a negative will be positive. Negative times a positive will be negative. All right, so now we do have a quadratic expression with a leading coefficient of 1. So I am going to use our quick method of factoring here by putting my 2 sets of parentheses. And again, do not forget that that GCF needs to be brought out there. All right, so we are going to grab that or take a look at this 12 right here. We're going to write that off to the side, and we're going to list all the factors of 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Which of those adds up to negative 7? Well, these add up to 13, these add up to 8, and these add up to 7. So again, 7 is the correct value number, but it's the wrong sign. In order to make it negative, we need to change both of them to negative. Now remember, not just one of them, because a negative times a negative will stay positive for this 12, and negative 3 plus negative 4 is negative 7, which is what we need. So this is our factor pair we're going to use. So we have x minus 3 and x minus 4. So again, this just combines that idea that sometimes we will first use a GCF, and then second, we will still have to factor using the methods that we've learned so far, and we will add additional methods in the future.